Hello everyone. I would like to make yet another update of my Bedini. The last video I pointed out I had some problems with cycling the both batteries I used, and someone pointed me out that I cannot swap the input, the charge and the source battery. You should only use one source battery and load that on a conventional way, and use a charging battery only for charging and use therefore the Bedini. And I was swapping them around, and that's not to seems not to work. Bill H pointed me to that, so I changed my battery setup. I have now a fixed source battery, and I use it to charge, to run the Bedini, and I have a fixed charging battery which I use to as being charged by the Bedini. For the source battery I use a conventional circuit with an LM, what is it, 317 LM317A, and it's this specific circuit. It's a modification for 12 volts, and it seems to load the source battery okay without problems. I also mentioned in my last update that I was not able to charge the charging battery more than 13 volt. It stays at 12.9. So, but even after I use this new setup with the batteries, I was not able to get over the 13 volt on the charging battery with my Bedini. So I was looking around why that was the case, and I even changed my 2N3055 transistor and installed another one. This one at the moment is now installed, the 2SC4570. It's a high voltage switching transistor, but it's not really improved the loading of the charging battery. It still did not come up above the 13 volts. So then I concentrated on the Bedini setup, and I'm going to tune it a little bit better. And what I found out is that you have several sweet spots, as you call it, and I was using the sweet spot where I have the minimum input current from the source battery, around 123 milliamps, and tune it for high speed and a single pulse. The upper trace, the red one, is the trigger. It's single trace. But then you see I only have about 20 milliamps loading on the charging battery. I used a 1 ohm resistor in both the input line to the Bedini as the output line. It's another exactly 1 ohm resistor, so I can measure exactly the result, the amps drawn and the amps output. But this 25 milliamps is not enough, I guess, to charge the charging battery. So I was looking about to improve the charging, and this is a very good way, I found out, to tune a maximum load. What I did is change the coil position to the magnets. I found that this position, I made a little notch, pencil strike on it, so I know exactly what it is, and then change a little bit with the potentiometer, and you see right away we have a lower RPM. We have 2 pulses now per magnet, but you see immediately the charge current is raised 40 milliamps. So this looks be much better. I have more amps drawing to the system, but okay, that's the penalty we have to take, I think. So I found out that now we can tune for another sweet spot. I will tune the potmeter now. You can see that the output current is rising. Also the current drawn is rising, but yeah, that's the penalty, I think. So I can raise it, the charging voltage, the current, to about what was it, 50 milliamps, I think. And then if I go too far, it drops. So sorry about that. I have to find out where the sweet spot is. Turn it back, potmeter back up. I guess this is the maximum I can tune it now. 45 milliamps. Position of the magnet could be a little bit there. So you have to really tune the distance between the coil and the magnets, and the current, and the base resistance. I should be able to get 50 milliamps output. If I turn too far, it drops, and you're past the sweet spot. So this is really a good tool, the resistors in the lines, to measure the... And what I notice now is that the voltage on the charging battery is increasing above the 13 volt. So I have not an output meter on it right now because I only have 2 meters. So you can fiddle around now with the new sweet spot to find the best optimum between the charging milliamps and the loading milliamps. But at least it's now charging better, the batteries, the charging battery. Another thing I was fiddling around is to see if somehow my core was saturated. So I took a magnet, a neodymium magnet, to see if I could saturate the core by entering it at the back. And you see, if I go near it, the amps are lowering, so it seems that my core is now saturated and not be able to get out much charge current. When I remove it, it raises again to the let me see if I can put it on both on one picture. Enter it, and it drops the current. When I flip the magnet over and use the other pole and enter it again, you can see that now the current is raising. And if I flip it on to the back of the core, I have quite raise in the loading current, the output current. So now the battery, the charging battery, will load even more. I can perhaps tune it a little bit better again. It was about 80. Now I'm past the sweet spot again. I have to back off a little bit and try it again. But it's much more than what we started with. So this has a good influence on the charging of the battery. Of course the input circuit is also drawing more amps now, much more. But yeah, what do you want? I mean, you have to charge the battery. The pulses are not really different. The RPMs is way down, but this way I'm able to charge the charging battery, and that's what's good. So somehow I think with this magnet I am now desaturating the core, providing more current. I have here this pole meter. I have of course the North poles on the batteries, and if I remove the magnet on the back side again, I can measure. Oops. I have south poles here, and if I check which side is used, which increases the current, I now have again a North pole here. That's wrong, it's a South pole of course. You cannot see that good. We do it the other way. So it's a South pole. I put a little less on it. Now if I put the South pole on the back, it raises the current. So a South pole against the South pole here will desaturate the core and will raise the current. So that's one thing I found out, and looks very promising now. I think I'm able to manage to get over the 13 volt with my loading battery. I will try to measure what it is right now. This is the charging battery. And it's now 12.9 and raising. So I think it's very handy to have the possibility to measure the input and the output currents of your system, to get the correct sweet spot, and not to tune just for highest speed or one pulse per magnet or whatever. And well, I can continue with this now to even improve it. So thank you for your watching and your comments if possible. Okay, it's now about 10 minutes later, and you see that the voltage is increased above the 13 volts. That's a thing that I did not get before, so it definitely is raising the voltage of the charging battery at the moment in this configuration. Thank you.